When I first got into electronics, I was really put off by the idea of etching my own circuit board. It seemed like a lot of trouble, hassle. I'd been using breadboards, like this one. They were just really temporary and fragile. And perf board is definitely more sturdy, but I found the layout process to be kind of confusing, and it led to a lot of mistakes. So finally, out of frustration, I did try etching, and I loved it. I could lay out a circuit any way I wanted and draw clear and visible connections between the parts. Now, there's a lot of different ways you can do this. The method I've found to be most effective is the photoresist. Let me show you. I'll start with a design.
There's a ton of PCB layouts available on the web, and most of them can even be built without knowing how they work first. Here's an audio synthesizer design that I made using the CADsoft Eagle program. The first step in turning it into a real board is printing it out. I've found these overhead projection transparency sheets to work pretty well for this. But I'm still not too impressed by the output of my laser printer. Might be time for a new toner cartridge. Any gaps in the ink can lead to tiny holes in my copper traces, which is not good. But that's why I always print out and cut 2 copies. By doubling them up, I usually block out any gaps, and I can always cover any remaining with a bit of precision Sharpie work. You can buy specialized exposure frames, but a cheap photo frame really works quite well for keeping the transparency pressed against the board. The shiny or unprinted side should face the glass, so that the ink can be as close as it can to the actual board. A small piece of tape will keep it from slipping around. I picked up the etchant, developer, and light-sensitive board I'll be using from Jameco's website. The pre-sensitized boards come with an opaque white film on them to avoid accidental exposure to ultraviolet light. In the past, I have opened them up in dimly lit rooms without causing any harm, but to be safe, you can use a red light source. Luckily, I happen to have a few red LEDs around. Peel off the protective film, making sure you don't get any dust or scratches on the board surface. Place the sensitized side against the transparency, keeping it centered, and replace the frame's backing. You don't need any special UV bulb for properly exposing the board. A common 13-watt CFL bulb works quite well at about 6 to 8 inches away. I'll expose the board for 8 minutes, which gives me plenty of time to make sure my developer's ready. I mixed 1 part concentrated positive type developer to 10 parts water in a Pyrex dish. These dishes are nice because I can even heat them if I need to, and they come with a lid so I don't have to remove the developer in order to store it. Once my 8 minutes are up, it is development time. When working with developer or etchant, I wear these nitrile gloves I picked up at the local pharmacy. They're very purple. Fully developing the board usually takes around a minute or so. Agitating or rocking the dish back and forth keeps fresh amounts of chemical flowing over the board and removes the unwanted resist coating that's flowing off. Once all of the exposed areas are all bright and shiny, totally free of resist, we can pull the board out and give it a quick rinse in cold water. At this point, you could scrape away any unwanted resist or fill in any holes that you spot with a fine point permanent marker. If everything looks good, then it's time to move on to the etching. There's a number of chemicals you can use for etching, but the most popular is probably ferric chloride. I'm using a mixture of 1 part concentrated ferric chloride to 1 part water. Now be careful, as this stuff will stain almost anything and easily mess up any metal surface. You'll definitely want to avoid skin contact and keep a well-ventilated work area. The entire etching process takes around 20 minutes. When I first put the board in, I'll agitate for about 30 seconds to a minute. Then I'll leave it alone, come back every few minutes to check on it, and agitate a bit more. This one's almost done, but still has some areas in the middle that need a bit more time. Once I'm sure all the exposed copper's been removed, I give the board another quick rinse and another close-up inspection. Looks good, so we're ready to drill. I'll use this mini drill press stand along with a 0.8mm bit for the component holes and around a 1.5mm bit for the wire pads. It's important to use eye protection and a dust mask while drilling. I also keep a vacuum hose close by to remove the excess bits that tend to pile up while I'm working. When I'm pretty sure I'm done, a careful look around the board usually turns up at least one hole that I've missed. Yep, there it is. Once all the holes are made, I use some nail polish remover and paper towel to wipe off the resist. Once the board is totally clear of resist, well, that's it. It's done. And it does look pretty.
And so, there we have it. A 100% homemade printed circuit board ready for soldering. It doesn't have the solder mask or through-hole plating that a board from a professional manufacturer would have, but it's got heart, something that those boards don't. I mean, I'm proud because I made it. It feels good. And I also made it for a lot less money and in a lot less time than if I had sent away to a manufacturer. So if you're considering trying etching your own circuit board, I do recommend it. It's really satisfying and it's worth it.
Materials used in this video are available as bundles from jameco.com.